Listen, I'll just read out these points about how to solve the linear homogeneous equations, but then once I take examples, these points will be more clear. I'll just read out for you, okay? So what you can do is just write them down, but you'll understand later why these points are true, okay? So see this, the number of linearly independent solutions of m homogeneous linear equations in n variables ax equal to 1 is n minus r, where r is rank of matrix A. So this point says that this is actually a theorem. I am not going to prove it. This is a theorem, but I don't want to prove that. It is a lengthy proof. So what I mean to say is, if you have ax equal to 0, the equation, then you take the quotient matrix A and you find out the rank of the matrix A. Once you find out the rank of the matrix A, then you see this number n minus r, where r is the rank and n is the number of variables. Then from that number you can say that the number of linearly independent linearly independent solutions is n minus r, and every other solution that you get is actually a combination of these solutions. Okay, so this set of n minus r is also called as fundamental set. Fundamental set means that is the basic set from which we derive all the solutions. So I'll just tell you what I mean. Let us say the number of linearly independent solutions you got as 1. Okay, see, for this equation ax equal to 0, what I mean to say is, you find the rank of the matrix A. Let us say rank of the matrix A is found out to be r. Okay, and now you find out this number n minus r, where n is number of variables and r is the rank, and let's say this you got as 1. Then what does it mean? The number of linearly independent solutions is 1. Let's say you got it as 2. What does it mean? The number of linearly independent solutions is 2. And one interesting thing is, let us say the linearly independent solution is 1, and let's call it as x1. If x1 is a fundamental set, right, or the fundamental solution, or one of the solutions present in the fundamental set, then k into x for any value of k is also a solution. Therefore, once you have one linearly independent solution, then you can frame infinite solutions, infinite solutions based on this linearly independent solution, but all the remaining solutions will be dependent on this. Okay, if you have two solutions, let's say x1 is a solution and x2 is a solution, then any combination of these two is again going to be a solution to ax, which means k1 into x1 plus k2 into x2 for any values of k1 and k2 is again going to be a solution to this. Therefore, we again have infinite number of solutions, out of which two are linearly independent and all the remaining are linearly dependent, and this is called as fundamental set. Okay, fundamental solution set. Okay, now what happens if it is equal to 0? It cannot be greater than, okay, let's see all the cases. Now watch it. So from this theorem we can derive some conclusions. Case 1 says that if r equal to n, if the rank of the matrix is equal to number of variables, then what happens? If this is the case, then n minus r is going to be 0, isn't it? Then the equation will have n minus r, which is n minus n. See, since r equal to n, n minus r becomes n minus n, that is, no linearly independent solutions are possible. So what does it mean? In this case we have only one solution, and that particular solution is 0 solution, isn't it? So in this case, if we have r equal to n, then the number of linearly independent solutions is 0. Therefore, the number of solutions is only 1, which is 0 solution. And the second case is, if r is less than n, then number of linearly independent solutions will be n minus r, and any linear combination of these linear independent solutions is again going to be a solution. Therefore, number of solutions will be infinite. I hope you are understanding this, the same point here. Got it? And the third condition is, if m is less than n. So what is m and what is n? This particular matrix A is m by n. m equations and n unknowns, right? So the size is this. Now if m is less than n, so I hope that you remember the one point about the rank of a matrix. A rank of a matrix cannot be greater than minimum of m comma n. If we have a matrix like this, we have already discussed it, if you remember it, R should be less than or equal to minimum of m comma n. I hope you remember this point. Okay, so now what is minimum among them? M is less than n, which means minimum of m comma n is m. Therefore R is less than or equal to m. If this is the case, then R is less than or equal to m, and we already know here that they are saying that m is less than n. That implies R is less than n, which is nothing but the second case. We have covered all the cases except one case. That case is R is greater than n. So this case doesn't arise. So why this case doesn't arise? You please work on that. You please work on the logic why this one doesn't arise. So these three cases are enough. So in the third case, actually it second case will apply, because I think you got the derivation right. M is less than n. Therefore rank cannot be greater than m, and so rank cannot be greater than n, right? And since rank is less than n, it is again the second case. So anyway, what I mean to say is, in order to find out the number of linearly independent solutions, you are first supposed to find out the rank of the matrix A, and once you find out the rank of the matrix A, you can talk about the number of solutions. Got it? Using these points. So what we shall see is, I'll tell you the rule or the procedure which we are going to use now, how to solve the linear homogeneous equations, and then we shall see lots of examples. So don't worry about all this. Even if you didn't understand anything of this, examples will make the point clear. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.